In December of 2018, Boca Chica unveiled images of what would become Starbase, the future home of SpaceX's Starship. At the time, few could have predicted that this tiny piece of land in a quiet Texas village would evolve into one of SpaceX's most pivotal facilities. However, nearly 400 miles away, nestled in another tranquil Texan town, lies a SpaceX facility that has been instrumental in the company's success from the very beginning. This is the story of the McGregor Testing Facility, a site with a rich history dating back to the 1940s, which has played a crucial role in developing some of the most advanced technology in spaceflight. In 1941, as the United States entered World War II, the nation faced an urgent need for an enormous supply of bombs. The government selected various sites across the country to establish large-scale munitions factories, and McGregor, Texas, was chosen as one of these locations. The facility was designated the Bluebonnet Ordnance Plant. Within months, the factory was operational, producing various types of bombs, some weighing up to 1,000 kilograms. Prior to the war, McGregor's population hovered around 2,000 residents. The establishment of the ordnance plant transformed the town, as workers flocked to the area with their families, swelling the population and invigorating the local economy. Much like how SpaceX's activities are revitalizing Boca Chica and its surroundings today. Throughout the war, the Bluebonnet Ordnance Plant was a hive of activity, at its peak employing over 5,000 people. However, with the end of the conflict, the demand for ordnance dwindled, and the factory ceased bomb production shortly thereafter. For a few years, the facility shifted focus, manufacturing furniture and kitchen stoves. But it was during the 1950s that McGregor began to establish its enduring connection to rocketry. The site eventually came under the ownership of the U.S. Air Force and was later acquired by Rocketdyne, a company that would test and produce thousands of engines for NASA's Apollo program. After a period under a munitions company, the facility caught the eye of an emerging private space enterprise aiming to develop heavy-lift vehicles. This company was not SpaceX, but Beale Aerospace. Founded in 1997, Beale Aerospace took over the McGregor site to test its rocket engines. In 2000, the company successfully test-fired its BA-2 engine, the largest rocket engine built since the Saturn V's formidable F-1 engines. Despite this achievement, Beale Aerospace closed its doors later that year when NASA declined to invest in the company, leaving the McGregor facility vacant once more. 3 years later, in 2003, SpaceX acquired the McGregor site to begin testing its Merlin engine. In the early years, SpaceX expanded the facility significantly, doubling its land area and increasing its workforce from a mere 3 employees to 140 by the end of 2011. By this time, SpaceX had successfully launched the Falcon 9, but the next hurdle was perfecting its ability to land and be reused. To achieve this, SpaceX constructed its first launch and landing pad at McGregor. The Grasshopper rocket, a testbed for vertical takeoff and landing techniques resembling the Falcon 9, was developed to practice these critical maneuvers. In September 2012, years of work culminated in the Grasshopper's inaugural flight, a modest hop that marked a significant milestone. The Grasshopper went on to perform 8 successful flights, each exceeding the altitude of the last. These tests validated the technologies needed for reusable rockets, a concept that would revolutionize the industry. SpaceX then progressed to testing larger prototypes that closely resembled the modern Falcon 9, continuing to refine their designs through both successes and setbacks. By 2015, Falcon 9 launches were becoming increasingly routine. With each rocket requiring 10 engines, the demand for testing at McGregor intensified. The facility expanded from 256 acres to over 4,000 acres, and engine tests occurred at an average rate of 2 per day. At that time, rockets were not reused, so every mission necessitated new engines and thorough testing. Comprehensive full-duration tests were conducted, wherein rockets were fully fueled and fired for the entire length of a typical mission while secured on the ground. Initially, these tests utilized the iconic tripod stand built by Beale Aerospace in the 1990s. However, as the Falcon 9 evolved and its power increased, a new, more robust stand was required to withstand the tremendous forces generated. The McGregor facility played an indispensable role in the Falcon 9's development. contributing to its status as one of the world's most reliable rockets and a pioneer in engine reuse. Achieving this level of reliability demanded relentless engine testing and development. SpaceX embraced a rigorous testing philosophy, pushing engines to their limits, sometimes to the point of failure, to identify weaknesses and improve designs. This approach mirrors historical practices. During the Apollo era, NASA faced challenges with the F-1 engine, particularly with combustion instability that caused destructive pressure fluctuations. To resolve this, engineers conducted aggressive tests, even detonating explosives within the engine to simulate worst-case scenarios. These dramatic tests were crucial in validating solutions and ensuring the engines could perform reliably under extreme conditions. Similarly, SpaceX's detailed testing regimen at McGregor has been vital in advancing their engine technology. The development of the Raptor engine, intended for the ambitious Starship program, has underscored the facility's importance. The Raptor 2 engine boasts a thrust of 230 tons, significantly more than its predecessor, and achieves this with reduced manufacturing costs. Daily testing of multiple engines has accelerated the program, with the company swiftly addressing any failures and resuming operations within hours. The constant testing at McGregor has not been without its challenges for the local community. Residents have experienced daily low-frequency rumbles, and some have reported property damage attributed to the testing activities. In response, SpaceX reached an agreement with the city of McGregor to limit testing after 11 p.m. and implemented a fine structure for any tests conducted during late evening hours. Looking ahead, McGregor's role is set to expand even further. With SpaceX's goal of producing hundreds of Starships, the demand for engines is unprecedented. For the first time, McGregor will not only test engines but also manufacture them. SpaceX announced plans to build a new factory on-site dedicated to mass-producing Raptor 2 engines. This facility aims to produce between 2 and 4 engines daily, amounting to 800 to 1,000 engines annually. Meanwhile, the larger Raptor vacuum engines and experimental models will continue to be produced in California. Although McGregor may not garner the same attention as SpaceX's facilities in Boca Chica or Florida, its significance cannot be overstated. From its origins as a World War II explosives plant to its current status as a hub of aerospace innovation, the site has come full circle, once again at the forefront of producing powerful engines and, metaphorically, explosions of progress. McGregor has been the proving ground for SpaceX's ambitions since day one, enabling the company to experiment, learn, and push the boundaries of what's possible in space travel. As SpaceX continues its quest to make humanity a multiplanetary species, the McGregor Testing Facility stands as a testament to the importance of perseverance, innovation, and the relentless pursuit of advancement in aerospace technology. If you have additional information on this topic to help us improve our upcoming videos, please share it in the comments below. Thank you for watching. Don't forget to like and subscribe to our channel to support us and receive the latest updates from X Universe. We value your support and look forward to providing quality content to all our viewers.